Hello all. In today's class, we are going to discuss error control in TCP. As we all know that TCP provides reliable service. Reliable service means flow control and error control. Flow control we have discussed in the previous video. In today's video, we are going to discuss about error control in TCP. The application process generates sequence of bytes which will be stored in buffer by sending TCP. The sending TCP is going to take the sequence of bytes from the buffer and segments will be constructed. The segments will be forwarded towards destination via network. In destination, the segments will be stored in buffer by receiving TCP, which is going to be forwarded to the receiving application process if there is no error. The objective of network is to carry the message from sending application process and to deliver it to the receiving application process. This will be facilitated by various protocols and the network. Since network is not reliable, the segment which is traveling through the network may suffer from various types of error. Those errors are corrupted segment, lost segment, out of order segments, and duplicated segments. Corrupted segment means because the network is not reliable, the segment which is traveling through the network may suffer from various types of noise interference, which is going to alter the bits in the segment, which means that the receiver may not receive exactly the same message which was sent by the sender. As a result of which, the receiving TCP will not be delivering the segment to the receiving application process, and hence the segment will be dropped here itself. Lost segment occurs when there is congestion in the network. As we had discussed in the previous video, that the various intermediate nodes in the network maintains buffer, wherein every incoming packet will be stored temporarily. So this incoming packet will be processed by the intermediate nodes and then it will be forwarded to the next node. Now, if there is congestion in the network, which means that if there are large number of packets in the network, then the incoming packet will not be able to be stored in the buffer, and hence every further incoming packet will be dropped, which means that the segment will be lost in the network. Out of order segment means the receiver is not receiving exactly the same segment which it is expecting to receive next. For example, receiver has already received segment 3. Now it is expecting to receive segment 4, but let us say receiver received segment 5. This segment 5 is out of order segment. In TCP, this out of order segment will be stored in buffer, but it will not be delivered to application process until receiver does not receive the next expected segment, that is segment 4. Duplicated segment is because of error in the network is delivering same segment more than once. Receiving TCP will be able to identify this duplicated segment, and this duplicated segment will be discarded or dropped here itself. All these errors needs to be detected and corrected, which means that error control mechanism in TCP is going to have two phases, that is error detection and error correction. So the error control in TCP is done by using two steps, that is error detection and error correction. So every type of error will be detected and hence the error will be corrected. So the first type of error, that is corrupted segment, this occurs because of change in the bits in the segment during transmission. So this will be identified by using checksum. Sender will be calculating checksum and receiver will be verifying the checksum. So if there is any bit that was altered during transmission in a segment, this will be identified by receiver by using checksum. And if the segment is erroneous, the receiver will not be forwarding that segment to the application process, and hence it will also not be sending acknowledgement to the sender. When sender does not receive acknowledgement within timeout duration, sender will understand that the segment suffered from error. The second type of error is lost segment. This will be identified by sender. That is, the sender will be transmitting segment and it will be waiting to receive acknowledgement. And within the timer, if the sender does not receive acknowledgement, it will understand that the segment was either lost or corrupted in the network. The third type of error is out of order segment. So when receiver does not receive next expected segment, then it will be sending acknowledgement with acknowledgement number as the number of next expected segment by receiver. That is, in the previous example, receiver will be sending acknowledgement with number 4. That is, it is expecting to receive segment number 4. Duplicated segment as well as this out of order segment will be identified by receiver by using the sequence number. And if a segment is duplicated, then it will be discarded, for which no acknowledgement will be sent to the sender. Error correction in computer is done by using two techniques. One is called forward error correction. The second one is called retransmission. In case of forward error correction, the position of the error will be identified and bit will be changed. Like in computer network, during transmission, because of noise interference, if bit was altered, then it will be identified by the receiver by using some algorithm. Now, once the bit position is identified, the value of bit will be altered. That is, if it was 0, it will be changed to 1. If it was 1, it will be changed back to 0. But this forward error correction cannot be done for a large data, which usually is there in network. So in computer network, using forward error correction is not possible. Though there are various algorithms that we can use like parity checker, but we cannot use in network because the number of packets, segments, and the amount of information is very large. So computer network goes to follows another type of error correction technique called retransmission. So TCP also follows the retransmission technique. So we are going to discuss this retransmission in detail in the subsequent slide. So all in all, up till here, you need to remember that TCP uses checksum, acknowledgement, and timeout tools to deal with error. Now we are going to see some of the error control tools in detail. The first one is checksum. So we had seen checksum in TCP header that TCP uses 16-bit checksum to detect error. So sender calculates the 16-bit checksum and receiver verifies the data, the segment which it is receiving using the 16-bit checksum to check whether the segment suffered from any kind of error or not. Another tool is acknowledgement. The receiver, once it receives segment successfully without any error, it sends acknowledgement to the sender saying that it has received the segment successfully. If the sender receives acknowledgement for any of its sent segment, it need not worry about that segment because the segment was received by receiver successfully. Now, but the receiver need not be sending acknowledgement for its segment that it receives, because sending acknowledgement for its segment will be increasing the number of packets in the network and hence the congestion in the network. So in TCP, the concept of cumulative acknowledgement has been used, wherein the receiver, instead of sending acknowledgement for each received segment, it may send one acknowledgement for set of segments. That is called cumulative acknowledgement. The next tool, very important one, is called retransmission technique. So this is the error correction technique that sender uses. After sending the segment, if the segment suffers from any kind of error, instead of correcting the error in that segment, sender retransmits it. This is also considered as one type of error correction. So in which case the sender will be retransmitting the segment which it had already transmitted to the receiver. For that, there are two cases. One is, for every segment that the sender transmits, it starts a timer that is called retransmission timeout timer, and sender will be waiting until the expiration of that timer. So until the expiration of that timer, if it receives the acknowledgement, it is fine. If it does not receive the acknowledgement, then sender will be retransmitting. This is the first case of retransmission, when the retransmission timer expires. The second case, when the sender will be retransmitting the segment, is when sender receives 3 duplicate acknowledgement. So this we will be discussing later on about the 3 duplicate acknowledgement. So up till here, just remember that when sender receives 3 duplicate acknowledgement, then also the sender will be retransmitting the segment. So we are going to elaborate each one of the case for the retransmission in detail. The first is retransmission after RTO. RTO is retransmission timeout. As I said that for every sent segment, sender starts a timer. And if it does not receive acknowledgement within the expiration of the timer, then it will be retransmitting that segment. So that is called retransmission after RTO. And when the timer expires, which segment will be retransmitted is, it will be the earliest outstanding segment. That is the first segment for which sender has not received any acknowledgement. So that segment will be. This retransmission timeout is calculated by using RTT value. That is, it is calculated by determining the time that the segment requires to move from sending process to the receiving process, and for the acknowledgement to move from receiver back to the sender. Now sender will be waiting until the expiration of retransmission timer, and if it does not receive acknowledgement within the timer, then it will consider that as error and it will be retransmitting that segment. Now the second case in which sender will be retransmitting the segment is when sender receives 3 duplicate acknowledgement. This is required in computer network because usually the value of retransmission timer will be very large. So for a sender to wait for that long duration, that is to wait until the expiration of retransmission timer, will be very long. So one solution to this one is 3 duplicate acknowledgement. Let us say if the network is not very congested, then the sender usually will be transmitting the segments, large number of segments, and if only few number of segment is getting dropped in the network or getting lost in the network, then instead of waiting for the expiration of the timer for that segment, we can use this another concept of 3 duplicate acknowledgement, wherein the sender will be able to identify the lost segment in the very earlier than the expiration of retransmission time. For example, let us say in this diagram, the sender has simultaneously transmitted 5 segments, that is segment 1, 2, 3, 4, and 5. Now segment 1 was delivered to receiver successfully, but segment 2 is lost. Now, for the sender to wait until the expiration of this timer for segment 2, you can see here the receiver has received segment 3, 4, 5 correctly. So that means receiver will be sending acknowledgement for segment 2 only. That is, just see in the first case, the receiver has received segment 1, so it will be sending acknowledgement for segment 2. But receiver is not receiving segment 2. It has received segment 3, 4 and 5. So receiver will be sending acknowledgement for segment 2 only, acknowledgement with number as 2 only. So that is, the sender is receiving 3 acknowledgement with same acknowledgement number. Now, let us say the timer for segment 2 is expiring sometime later in future. But before that only, the sender is able to identify that receiver has not received segment 2, but receiver has received the segments following segment 2. So from here, sender, instead of waiting until the expiration of segment 2, it can retransmit segment 2 here itself. Okay, and it can reinitiate the timer for segment 2. This is called fast retransmission. So here you need not be waiting until the expiration of the timer, but if by using this 3 duplicate acknowledgement, if by using the remaining segment that was sent after that lost segment, using the acknowledgement of those segments, if the sender is able to identify that the segment was lost, then sender can retransmit that segment. So this is called fast retransmission. So next we are going to see how TCP executes this error control mechanism. So this is the normal operation that is being shown, wherein no error has occurred in the network. So sender has transmitted a segment with sequence number 1201 to 1400, which means that its data byte is starting from 1201 and it is going up till 1400. Now client is expecting to receive a segment from server with number 4001. Okay. Now server, after receiving this segment from the client, it is sending acknowledgement as well as its own segment. So this is called piggybacking, wherein the acknowledgement has been sent along with the data. So sender is sending a segment with sequence number which client was expecting to receive from 4001. So server is sending from 4001 to 5000. And server is acknowledging that it has received all the bytes up till 1400. Now here, the client, before sending the acknowledgement, it is waiting for 500 milliseconds. It is because the server may send the more than one segment simultaneously, like we had seen about the previously, that a process can send multiple segments simultaneously to the other process. So if client is about to get more segments from the server, then instead of sending acknowledgement for each segment, client can wait for some duration. If it receives other segment, then the acknowledgement number will change. If it does not receive the acknowledgement, then client is sending the acknowledgement for this segment which it has received. So client received segment, okay, with data byte up to 5000. Now client is expecting to receive next data byte, that is 5001. So it is sending acknowledgement with number 5001. Now server is sending data for the client request, that is its number is starting from 5001 and it is going up to 6000. Now server still is expecting to receive next data byte, that is 1401, same as that of previous segment. Again client is waiting for 500 milliseconds. It may wait for less than 5 milliseconds. Now within 500 milliseconds, client received another segment with number 6001 to 7000. So as I said, we can use cumulative acknowledgement in TCP, wherein instead of sending acknowledgement for each segment separately, client can send acknowledgement for the next byte, okay, considering both the segments. That is, client has received data bytes up till 7000, so it is sending acknowledgement with number 7001. So next expected byte the client is expecting to receive is 7001. This was the normal operation. Now let us see when error occurs, how the communication takes place. So Let us say for both lost and corrupted segment, the process is going to be same. Because if the segment is corrupted, then also the receiver is going to discard it. Discard means the packet will be lost. Now let us say in this example, sender transmitted 2 segments which receiver received successfully. So receiver stored those 2 segments in the buffer. Now sender transmitted 3rd segment which got lost in the network or which was erroneous, so receiver discarded that. So that segment is not there in receiver's buffer. Now sender transmitted another segment which receiver received successfully, so it is storing in the buffer. So when receiver will be storing that segment in the buffer, it will find out that the segment is out of order segment. So the previous segment was lost. Okay. Now the receiver, when it is sending acknowledgement, it is expecting to receive byte number 701, which was lost in the network. Even though it received byte number 801 to 900 successfully, but it is still expecting to receive 701 to 800. So it is again sending acknowledgement with number 701. Now, if the value of retransmission timer is very small, okay, that is before receiving 3 duplicate acknowledgement only, the sender's RTO value for that lost segment got expired, then sender is retransmitting that lost segment, that is segment with sequence number 701 to 800. So receiver, after receiving that segment, it is storing in the buffer and then sending the acknowledgement, that is from 901. Remember that TCP, whatever segment it is receiving successfully, it will be storing in the buffer, but it will not be delivering it to the receiving process. It will store here until it does not receive the lost segments. Now, when fast retransmission occurs, as I already said, when the value of retransmission timer is very large and before the expiration of retransmission timer only, the sender receives 3 duplicate acknowledgement. For example, here, this particular segment was lost in the network, but receiver is receiving next 3 segments successfully. So for every successfully received segment, receiver is sending acknowledgement. So in the acknowledgement, the number that receiver is using is the number of that lost segment. So receiver is sending acknowledgement 301 for this segment which it received successfully. Then again it is receiving another segment which it is storing in the memory and sending acknowledgement with number 301, because receiver, here you can see it is still expecting to receive 301. Now receiver received the third segment which it is storing in the buffer, but then in the acknowledgement it is sending number as 301 again. Here you can see up till here sender received 3 duplicate acknowledgement, 3 acknowledgement with same number, which means that the segment was lost. After that segment, 3 remaining segment receiver received successfully. So that means sender will have to retransmit that segment, that lost segment. So sender is retransmitting that lost segment. Then once receiver receives that lost segment, it is sending acknowledgement for next expected byte. So up till here, up till byte number 700, receiver had received successfully. So now receiver is expecting to receive byte number 701. So which receiver is sending back to the sender.